Welcome to Code Report. I'm your host, Connor Hoekstra. Just as an FYI, you might have noticed that I didn't post any additional videos this past week other than the regular Sunday episode. My schedule is a bit crazy right now, so over the next 2 to 3 weeks, there'll probably be less uploaded videos, but after that period of time, I hope to get back to the regular 3 to 4 uploads a week. That being said, let's take a look at the contest that happened last week.
We had 5 contests last week, starting off on Monday with the Codeforces Educational 44. On Wednesday, we had the start of the Hacker Earth Maze Circuits contest. That's a 9-day contest that will last until next Friday. On Friday, we had the Hacker Rank World Code Sprint 13, which was a 48-hour contest that ended today, starting at noon. And on Saturday, we had the Code Chef Lunchtime that started at 10 and the weekly Leak Code Contest 86. Taking a look at the top 10 leaderboards, here they are. We had Yui placing on 3 of the top 10 leaderboards, and Tourist, otherwise known as Gennady, placing on 2 of them. So Yui placed 9th, 8th, and 5th, respectively, on the Codeforces Hacker Rank and Code Chef, and Tourist placed 7th and 1st in the Hacker Rank and Code Chef contests. In today's video, we're going to be covering the solution to problem 2 from Leak Code Contest 86 entitled Keys and Rooms. The problem states there are n rooms and you start in room 0. Each room has a distinct number in the range 0 to n-1, and each room may have some keys to access other rooms. Formally, each room I has a list of keys rooms I, and each key rooms ij is an integer in the range 0 to n-1, where n is equal to the number of rooms. A key rooms ij equals v opens the room with number v. Initially, all the rooms start locked except for room 0. You can walk back and forth between rooms freely, and the question asks us to return true if and only if you can enter every room. And note that the number of rooms is going to be between 1 and 1,000, and the number of keys in all rooms combined is at most 3,000. So let's take a look at one of the examples that Leak Code provided us with. So here's the input. This basically means that we have an array of length 4, which means there's 4 rooms numbered 0, 1, 2, and 3, and each of these arrays at each of the indices represents the keys that each of those rooms hold. So we can sort of look at this visually as this. Here are 4 rooms, 0, 1, 2, and 3, and in each of these rooms there are keys to open other rooms. So we start in room 0, and then we can go and open room 1 and room 3. And once we're in room 1 and room 3, from room 1 we can get to 3, 0, and 1, and from room 3 we can get back to room 0, and room 2 only has a key to itself. So we can think of this basically as a graph theory problem that's asking us to figure out if there is one connected component in this graph. So we want to see if we can get to every single node in this graph. So we can visualize this as such, and so gray means that we currently have this room locked, and 0 means the blue means open. So we start off with only room 0 open, and the way we're going to solve this is with a stack and with a hash set. So stack will represent the rooms that we need to explore, and the hash set done is going to represent the rooms that we have explored. And we're basically going to do depth first search, and you can also use a breadth first search, BFS, instead of a DFS, but both will work, and you just need to check that you can get to every single room. So you'll do your DFS or your BFS, and then at the end of it, when you've explored all the rooms that you can explore, you will check to see whether your hash set done has size equal to the number of rooms. If so, you return true, meaning you could explore every single room. If not, you return false, meaning that you couldn't explore every single room. So if we walk through this problem, we'll start in room 0, and here we'll check to see that our keys we can get to other rooms are 1 and 3. So here we're sort of drawing a direction 0 to 1 and 0 to 3, meaning those are the rooms we can access. And so we've now added 0, 1, and 3 to our done hash set, and in our to-do stack is 1 and 3. So next we'll look at room 1. From room 1 we can get to room 3, 0, and 1. All of these have been done, so we can add some arrows, but we're not exploring any new rooms. Then we'll process room 3, which you can only get back to room 0, and so that's not going to add anything. So then we've emptied our to-do stack. So at this point we're going to check if our hash set has the same size as has the number of rooms, which it doesn't. And so this last key you can only get if you're currently in that room, so we can't access it. So this example, we would return false. So that's the general idea. It's a pretty straightforward problem if you're familiar with BFS or DFS algorithms. And yeah, so let's take a look at our code. So here is our C++ solution. We've got our function that returns a bool, either true or false, and it takes a vector of integers as its input for its parameters. So the first thing we do at the top here is we initialize our stack of integers, which is going to represent the rooms that we need to explore. And then we're going to push onto this room 0. That's the room that is only starts open. And then we initialize our hash set, so unordered set of integers called done, and we're initializing this to start with room 0 as well. So then we have our while loop that's going to loop until we've emptied our to-do stack. So then we're going to pop off the top room from our processing stack, and we're going to pop that off once we've stored it in top. And then for each of the keys that we can access other rooms, we're going to loop through, and we're going to check if it's not already been explored. If it hasn't, then we are going to push it onto our to-do, and then we're going to insert it into our done. And so this is sort of the key part, inserting into our set done. And at the end, once we finish this while loop, we just return whether or not the size of our hash set is equal to the number of rooms that we started with. So let's take a look at the Java solution. Very similar, just slightly different syntax. So initializing our stack of integers and our hash set of integers, the same while loop and the same for loop inside, just slightly different methods. So .get, contains, and .add, and we have the exact same condition at the end, checking to see whether the size of our hash set is equal to the number of rooms that we have. So last but not least, we have our Python solution. Here we can use a list as our stack because it has the methods that we need to treat it as a stack, and then we declare our hash set here, which is equal to have the name done, and then once again we have our while loop and for loop, just slightly different syntax and different methods, append and add, and once again at the end we are just checking whether the length of our set is equal to the length of the number of rooms we started with. And the last thing to talk about is the time complexity. So because we're only at most visiting every room once, this will have linear time complexity in the number of rooms that we have. And also thank you to Lee215. I used his solutions that he posted on the LeetCode forum when I was building my Java and Python solutions. Taking a look at the contests we have next week, on Tuesday we have the Codeforces Round 485 for Division 1 and 2. Moving along to Friday, we have 3 contests. From CodeChef, we have the June Long Challenge that starts at 5:30 a.m. and will run for 10 days. Then we have Codeforces Round 486 for Division 3 at 11:35 a.m. And from Hacker Earth, we have the June Easy contest starting at 12:30 p.m. Moving to Saturday, we have the second round of the TCO 18 contest put on by Topcoder happening at noon. And then in the evening, of course, we have the weekly LeetCode contest 87 at 9:30 p.m. And on Sunday from Hacker Rank, we have the Hour Rank contest number 28 starting at 11 a.m. And as well as previously mentioned in this video, we have the Hacker Earth Maze Circuits contest running until Friday.
As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.